my introduction today, the beginner's talk, is we're just going to cover some basic file I/O. I/O, for those of you who may not know, is just input-output. That's common, very basic thing that most programs need to do. They need to get data from outside of the application itself, and then they need to process it in some way, and then they need to potentially push data outside of the program itself. Files from the file system are one of the most common ways to do that I/O give and take, and so we're just going to look at some basics about what we can do with files in Python. I like interaction. I'll probably ramble a little bit more than I should if you're not asking me questions, so feel free to ask questions, especially during the beginner's talk. This is a great time for those of you who are just getting in and you just feel like I don't know at all what you're talking about. Feel free to raise your hand and ask. I'll do my best to explain. If I feel like it's going to rabbit trail us too much, then I'll just pass on it and be happy to talk to you after the evening to try to answer your question. Yes?
So I explained the I/O before. So is it part of Python, or I've noticed that you can also download or install other libraries to do I/O. I was trying to do a file copy and it blew up because it was already in existence.
Okay.
So are you using Pythons?
That's a very good question. Everything, so the libraries that come with Python are called the standard library, the Python standard library. And one of the nice things about Python is it has a lot of tools built into the Python standard library. So to answer your question in particular, everything that I'm going to show you comes directly from Python. This is built in. I'll be using Python 3. I think at this point, most of you should probably be using Python 3. Python 2 ends of life in January. I don't think there's much here that's really Python 3 specific, although we are going to do a little bit with file encoding at the end, and that is a bit different between Python 2 and Python 3. But since this is a beginner's talk, I'm just going to mention that that's something for you to be aware of. I'm not going to delve into it very deeply. Any other questions? That was a really good question, by the way.
And built-in means it comes with the standard install, but it's not necessarily available until you reference.
Yes, that's right. So the way Python is made, you only have access to the built-ins in terms of your namespace, the things you can just call. So you'll still have to import some things, and I'll show you here in this first step the difference between the built-ins that are just immediately there and usable, and then the things you have to import at the top. But yes, that's a good distinction as well. Most of the stuff that you use in the standard library, you're going to have to import at the top of the file to get a reference to it, but it's still built in. The other thing that you can do is install libraries from outside of the Python standard library. The most typical way to do that is with pip. Pip installs packages, and again, that's a little bit beyond the scope of this talk, so I'll just let you know that if you want to learn more about that, just Google pip. And read what it does in terms of installing packages from outside of the typical Python standard library. Anything else? Okay. So the first thing I'm going to do, the first thing most people want to do with a file is read it. That's all I want to do. I want to open a file. I want to get the contents. I want to get the stuff that's in it, and then I want to do something with it. So in this case, I'm going to pick my file name, which I've already committed in this repository. By the way, this code, if you want it, it's really simple. I don't know if you'll need it, but if you do, we have a DerbyPy GitHub space. GitHub is a repository for code, if you're not familiar with it. So if you Googled DerbyPy GitHub, you would find our repo, and this repo would be at the top of the list because I just added it, so you could find it. I also left a comment with a link to that repo in the event, the meetup event comments for this particular event, if you want to go out and see some of this code. So I want to open a file and I want to read its contents, and then I want to do something with it. In this case, the do something with it is I just want to print it to the screen. So whatever terminal I'm running this code in, I want it to end up on standard out, which is, I'm not going to go into that. Just I want it to show up when I run the program. Okay, so This is what was in my file. If any of you are familiar with the cat program in Linux, all it does is dump the output of a file to the screen. And so I can show you that this file is indeed Do You Like Star Wars? So I basically did the same thing with the cat command as I did with my Python file. I just took all that data, whatever's in the file, and then I dumped it out to the screen. Questions? Go back to the code. Yes, sir.
How come there's an empty line after the Python version?
I was hoping somebody would ask me that. Anybody want to jump in? Why does this have an empty line? Why do I have an extra new line character in here when I don't with cat? Say it again? Yeah, that's right. So this file actually has a new line character in it. So if I was to open this and look at the file, see we have actually 2 lines there. I could delete one, but my Visual Studio code is set up to always add one when I save it. So it's actually it's really difficult for me to get the file without the new line. The new line is in the file. So when I read the contents, I get a new line character. That's not helpful. When I read the contents, I get a new line character, and then the print adds a new line character after it. And so that's why I end up with 2 new line characters, an extra line. That's a really good question. Say it again?
Print doesn't add it, it's actually in there.
There's 2. So print adds 1. Print does add 1.
At the end of the file output, new lines on the terminal.
Yes, exactly. That's why, actually, if we didn't have 1, that's not going to do it, is it? No. How do I get Vim? Anybody know how I get Vim to remove that new line?
Isn't it the end after the quote mark? Question?
I don't know. I was expecting it to have a
Hit X there.
hit X.
Yeah. And then
I don't think that's what I wanted. Well, let's see. No. Oh well. We'll skip that for now. But if I could remove that new line, I would actually get this prompt would be up here next to the output. Is what would end up happening, and that would mean I don't have any new lines. Any other questions about this code? Speaking of built-ins, open in this case and print are both built-ins. Those are both functionality that you have access to without importing.
what if the file's really, really big? Would I do it the same way?
Okay, so if the file's really, really big, it's going to depend on relative of really, really big to your memory size. Because read is going to take all of that data that's in the file and it's going to put it in memory so that contents can refer to it. There are different techniques to deal with that. I'll actually show you one in just a couple more steps about how you can, if you have a file you need to, you're able to process sequentially, you can really reduce the amount of memory that you need to process that file. Another great question. Thanks for leading. Anything else? Okay. What if I forget to close the file? So that was a really good observation. Notice that I open here, but I don't close that file object anywhere. Some of you who are more familiar with C may want to call this a file descriptor. This is not actually true in Python. It's actually a file-like object. There's a file descriptor involved, but it's kind of buried. So this file object actually has more stuff that it's giving you than simply a file descriptor, an operating system file descriptor. I was going to try to get the resource warning to come up, and I just couldn't get it to come up. I don't know if I've got my warning set to hide it or something. So unfortunately, I don't have an example of that. But it's possible sometimes if you don't close a file, that Python will give you a warning that file was not closed. It's going to go ahead and close it for you. So Python is going to close file objects when they go out of scope and they're garbage collected. But it's actually better, and I'll show this in the next file, it's actually better to use a context manager to make sure that they always get closed. 97% of the time, it's not going to matter. Python's just going to do the right thing. You're going to code and go on with your life. And then that 3% of the time when it does matter, you're going to beat your head against a wall for hours trying to figure out why your file doesn't look right. And it's going to be because you accidentally have a file handle or a file object open and something weird is going on interacting between two open file objects. All right, so let's look at the second file. One of the handy libraries that comes with Python is called pathlib. This is part of the standard library. You don't need to install it. If you have Python 3, it's there. If you have Python 2, you would need to install this manually. It's in the Python 3s you should be using. if you're using a Python 3 that does not have pathlib, you really need to upgrade. I think that's a safe bet. So I've got a couple print statements here that are going to help us understand the objects, the type of objects that we're working with. I'm using the built-in repr, which gives us kind of a systems view of the object that we have. Like, what is this thing? Not just what's a pretty representation of it, but what is it actually? So we're going to see the difference between underscore file, or dunder is what those underscores at the beginning of the underscore are called. So dunder file gives us a path to the current actual file that variable is in, and then I'm going to feed that to the path object here to get me a more user-friendly way of interacting with that path than to just have the string. We are going to replace, so I didn't want to, if you recall in this, I had to name my file, and I named it the same as my Python file with a .text extension. Well, it made sense to me to just do that automatically so that every file I was working with was the same as the name of the Python file with a .text instead of a .py extension. Does that make sense to everybody? So I'm going to go ahead and run this code quick so you can see what I'm doing there. So the file that I'm running, which you can see right here, is o2pathlib.py. I've converted that to that path object, and because I'm running on Linux, this actually, Python does some things behind the scene. The pathlib library understands the differences between Windows file access paths and Linuxy file paths, which are actually POSIX standard, and which you would also have on if you're running Mac OS X. I guess Mac OS now. So I want to get that path object because it lets me do things, and I can kind of forget whether I'm on Linux or Windows or Mac. I can just kind of use the file, and that's what I want to do as a developer. I want to abstract away the differences between platforms for the most part. So notice I have .py here, and again I told you I wanted to use the same name with .text, so that pathlib gives me a really handy method here, a utility method called with suffix. This is a common thing we do as programmers. I want to take this exact thing, and I just want to change the suffix or the, let's see, what do we usually call this?
Extension.
The extension, thank you. I want to change the suffix or the extension. So I'm changing from .py to .text. And so now, and then I'm going to open that. Okay, so I didn't even do this right. I wanted to do this. There we go. So now that f name is actually a path object, it gives me a .open method. I don't have to feed it the name anymore. And this also, for reference, anytime you have a with statement like this, you're using something called a context manager. I'm not actually going to go into that because I'm already way over time. But context managers are important. They sound, when you see this, you're like, oh my gosh, what's going on? Especially as a new person to Python. If you just Google context manager and read a little bit about what it's doing, it's actually really simple behind the scenes what's going on, and it's really handy. The main thing that this is going to do for you in the file context is it's going to close that file as soon as you leave the with block. So as soon as I'm outside that with block, Python is going to take care of closing that resource for me. There are a lot of, it's very Pythonic to use context managers to close resources when you're done with them. So you will see this pattern over and over and over again in good Python code. Okay, so I've picked my file. I've changed a little bit how I'm using it. I'm no longer using the open built-in. I'm instead using the open that comes with the path object, which essentially does the same thing as the built-in. It just lets me be a little bit more object-oriented. I am going to read the contents of that file. I'm going to strip it to get rid of the new line. And then I'm going to show you the type of that object, and then I'm going to show you the actual contents. So some of our debug output here, the type of contents is class string, and the contents is, do you like Star Trek? You see a theme here yet? All right. Any questions about this? PathLib, wonderful library. Okay, so in addition to reading, we often want to write files as well. In Python, your open functions have a context of mode. Mode tells Python how you plan to use that file. By default, Python assumes that you have a text file and that you want to read it. In this case, we want to write it. So implicitly here, the default would be the same as having this present. There would just be an R passed in as the mode, which tells Python read, and actually, if we're going to be really specific, it's going to be RT for read text. In this case, in the write, we want to change to write. It's going to be text by default. I don't need to specify that. If I wanted to, I could, and it's not going to make any difference because that's already the default. Any questions about writing?
Is there a way I can pass an argument to let it know not to overwrite a file that already exists?
Not to overwrite a file that already exists. Yes, there is actually. If you look at the open documentation on the Python website for open, one of the modes was open exclusive, I think, and it will fail if the file already exists. The other thing you can do pretty easily with pathlib is fname.exists, like that, and that will give you a Boolean if it exists or not. So it's pretty easy to do your own error handling too if you want a kind of an extra layer of protection.
Will write always write as a class type string?
Ask the question again.
Will always, like when you write to a file, will always write, like will Python interpret that as a string?
That's somewhat of a loaded question because at the end of the day, the contents of a file are always bytes. And whether it's a string, which means in our case in Python, it would be Unicode, and we're going to get to encoding in just a little bit. Python is going to take what you give it and it's going to try to turn it into a string. If it can't, it will give you it'll try to interpret that, take it from string to bytes. And if it has a problem doing that, it's going to do that usually as UTF-8 encoding. And so if you give it something that's not UTF-8 and it can't do the conversion to bytes, it's going to blow up. So there is some encoding magic going on behind the scenes. In Python 2, it'll just happily write whatever it can to the file and you won't even know there's a problem until later. That was one of the big differences that Python 3 made, was they started making that stuff explicit. So in the Python ecosystem, objects can represent themselves as strings. So it's very possible to hand this an object that's not a string, but if that object has the correct protocol, Python behind the scenes will get the string content and will write that. So it's not as easy a question to answer as I might hope.
Sure.
Any other questions about writing?
Will it write to the beginning?
Say it again.
Will it write to the beginning, to the end, or will you replace?
Good question. So there are multiple modes. Again, a write will automatically overwrite from the beginning. It'll truncate. We'll show you an append option here shortly, which will, instead of overwriting the current data, will append instead. Any other questions? Okay. To answer your question, write truncates. So with this example, we're going to open the file. We're going to write Star Wars to it. We're going to close the file implicitly because we're going to come out of that with block. We're going to open that same file again with another write, and we're going to write Star Trek. So what's going to be in the file? Star Trek is going to be in the file because write truncates. Oh, I guess I didn't demonstrate that right, which is fine. We'll keep going. And the content is Star Trek because the contents that was written there first, it was there. That file actually had Star Wars in it for just a moment until the second open truncated that file, wrote content over it, and ended it and closed it. Any questions on truncate?
Yeah, so you're using the word truncate in a different sense than I know. You're saying truncate means overwrite.
Yes. And I'm not exactly sure about all the internals that are going on, but at least in the docs, they say when they write the file, when you write the file, it truncates it. And I'm pretty sure the reason that they say that is because if you had a file, let's say with 100 bytes in it, and you overwrote just the first 3 bytes, all of that other stuff is going to be gone. The last 97 bytes are all going to be gone. So there is actually a truncate, and I'm not exactly sure how it works underneath the covers, but you're not going to have that other 97 bytes hanging out anymore. That file is going to end up with the 3 bytes that you wrote it, and that original 100 bytes is gone. Any other questions for truncates? Okay. Okay, so we talked about truncate. Now we're going to see append. Okay, so the first one is going to be a write. The second one is going to be an append. And the third one is also going to be an append. So we should end up with how many lines in the file? How many lines of content? We should end up with 3. Follow my storyline? Don't get so focused on the Python that you miss the storyline. All right, any questions about append? Where do we, what is the thing you think of first when we say append to a file? What comes to mind? Logging. Great. That's what logs do, right? They just keep adding to the end until you get a log rotator that comes in and helps you so you don't fill up your disk. Okay. I missed one earlier that I meant to show you.
Explain what logging is?
Yeah, logging. So a lot of applications need a place to store information when it's operating. So if I've got a process on a server, I've got a website that's running, various things could be going on that as a developer I want to have access to after the fact. I want to know the sequence. So a great one might be an audit log for users logging in. I don't actually want like an email or a Slack message coming to me every time somebody logs in. I mean, think about that, what we do at some place like Google, right? But I may very well want access to who logged in later for security purposes or to measure the number of logins I have in any given day. And so logging is the process of taking that data from a program, getting it out of the program somehow, whether that's to a disk or a network logging server, and then usually taking even those logs and shipping them somewhere else. In a bigger organization, you're going to have a whole pipeline set up for how you manage your logs, get them to a place that people can view them, and then put them in kind of longer term storage for archiving.
So in this context, you would have logged 3 different actions?
In this context, I'm not really logging. I'm just putting it on the output. If I was logging something that would usually go kind of behind the scenes, you might not even see it on my screen, but I would have a file later I could go to that would have all the log output in it. I mean, I can show you an example of that if you want to. So this is my system log here. And there's all kinds of stuff that's going on in the background that is being logged to that file that if I wanted to come at and look at later to get an idea of maybe something that's gone wrong or do some kind of audit, I could go look at that stuff and see what's going on my system. I don't have to be notified of it in the moment. It would be completely overwhelming, but I've got a place to go look at it later. I missed one thing here. I do have a file here called shortcuts. File called shortcuts. There it is. One really handy thing to know, and I think we actually talked about this earlier, is this file object is actually an iterator. So you can iterate over it line by line. So if we... No, I don't have it.
When it does that, does it read the whole file into memory, or is this how you would open large lines without?
Yeah, so this does not load the whole file into memory. This loads only the current line into memory. And so if you have a 20 gigabyte file that you need to do some log processing in, and you're on a machine with 8 gigabytes of memory, and as long as you don't need all of it in to do your processing, you should be able to process line by line every one of that, and you only need as much memory as the longest line that you're going to read, which makes a big difference for a lot of things that you're doing.
And Randy, is that just the open that comes in PathLib, or is that the regular open as well?
It's both. The open that comes with PathLib is essentially the system open. They do the same thing. You just get at them a little bit differently. Iterating over a string, remember that, or over a file object is really helpful for a lot of different things that you might do. Okay, so we were at append. So what do you want to do? What should you do when you want to do both? So let's think about something like a search and replace in a file. Okay, I've got something in the file. I want to read what's in the file. I want to replace something in it, but then I want to write it too. So far we've seen read, we've seen write, we've seen append. What do we do if we want to read and write? No, actually. All right, here's what we're going to do with this one. We're going to write Star Wars rules, and then we're going to show you that content's actually in the file. I could have started off with the file with the content I wanted, but then I'm going to overwrite it, so it had to constantly be resetting it. This is also another handy PathLib shortcut. A lot of times we just want to put data into a file or get data out of it. It has a read text and a write text shortcut that saves you from having to do the context manager, and it'll handle all that stuff behind the scenes. So I'm going to put Star Wars rules in the file. I'm going to show you that that's actually the content. Okay, current file content, Star Wars rules. Because I've read the text. Now I'm going to do some processing on that file. I'm going to open it in read plus mode, which is how we tell it I want to read and write. I'm going to do some string replacing. Can anybody tell me what this is going to make the string be? What is it?
Star Wars rules.
Star Wars rules. I had to. And there's going to be a little, tongue stick out face at the end to make it, hopefully funny a little bit more. All right? No, because then I would have had to explain encoding, and I just don't want to get there. I'm going to get that at the end. Okay, so I am going to say this is going to be wrong. I'm missing something right here. And then I'm going to write the contents. So I'm going to do the string replace. I'm writing the contents, new file contents. Who can tell me right now the way the code is, what's going to be in the file when I'm done? The smiley is going to be in there, but it's not the whole thing. What's the whole contents of the text file going to be?
It's going to have both Star Wars rules, Star Wars rules.
It's going to have Star Wars rules and Star Wars rules, and let me show you what that looks like, and then we'll talk about why. All right, so new file contents, it's both. We started with what we had, and then we ended up with the additional content appended to what we had. Just to show you that that's actually what it is. We'll use cat, and you can see it. Oh, hey, look, there's the new lines missing. I don't have a new line. See how my prompt gets stuck at the end?
Are you picking up a space at the beginning of your line and print out Star Wars rules?
Yeah, I am. Just kind of indented a little bit to show that it's...
But I didn't see the code.
Let me punt on that just because I'm running out of time. Okay, so the thing that we have to remember if we're going to read and write from a file, I could have used write plus here, W plus, in which case that file would be truncated at the beginning, which actually wouldn't do us for any good in this case because I'm already writing the text up here. But the thing you have to remember is that in files, there's actually an internal pointer to the location that you are in that file. And so what's happened is when we read the first time, that pointer got moved all the way to the end of the file. When we wrote starting where that pointer is and continuing on. So what we're going to have to do is, if we want to overwrite the contents of a file, we're actually going to have to reset that pointer to the very beginning of the file or somewhere above where I want to actually start the write. So in this case, the way that we do this is we do file object.seek. And so that's kind of like seek that pointer, move it around to the location that I give you, and I want to seek it to 0. So that's going to move it all the way back to the beginning, and then I'm going to overwrite the content that was there. And now my contents is what I intended it to be, without the additional what was there to begin with.
Brady, what would happen if you set it to, made it seek to 10, for instance?
I think I'm still in the length of the file, so I think it's going to be, it's going to truncate just a little bit of it. Let's see, 4, 5, 6, 7, 8, 9, 10. So what I should see is Star Wars space and then Star Wars drools. Yeah. Does that make sense?
Yes.
So I'm just seeking along, and again, we're dealing with bytes. We're not actually dealing with text here. We're dealing with bytes, and so we're just moving that kind of marker back and forth in the bytes to tell Python where we want it to do its next movement.
How is seek affected by a text file that would have Unicode characters in it?
You know, I don't actually know for sure, but I think that seek is not bytecode aware, so I think it's actually going to go to whatever, or it's not encoding aware, so it's not going to like try to figure out what that text actually is. It's just going to go to that position in the file, and if you happen to put it in the middle of a character, Unicode character, you know, you're going to have all kinds of problems.
Is there also like a write helper that allows you to just I guess like truncate and then write, or is it like another helper basically to not have to write seek every time?
If you just want to write and you don't care about the contents of the file that exist, then you don't need to use the plus. You can just go back to the write. So if you just put a W in there, the current contents would be overwritten. But in that case, you couldn't read them. So remember, some operations, you're going to actually want to operate on the contents of the file and then change the data that's in the file based on that operation. That's when you need the plus operator so that you can both read from and write to that file.
If you ended up writing a shorter string than what you originally had to the file after seeking, what would you do to truncate the rest of the file?
I don't actually know. That's a good question. I'm wondering myself if it'll be there. There you go. That's your answer. The data is still there. If you want to truncate the file, you shouldn't be seeking. Yeah.
So you probably want to read it into memory and then open it again in write mode and then truncate it. Then
You can actually call. Let's see.
there's like W plus, but
Nope. I thought truncate was a. It must have worked because. Oh, I bet you have to call it after. There you go. You can do it yourself. Seek is often used for files that have structure in and of themselves, where you're actually doing random access instead of sequential. If that's helpful, just keep that in mind. I very rarely do a in-place copy just because or an in-place replace, because you always have the risk of kind of damaging, you know, what you're reading, and so a lot of times it's better read it, write it out to something, and if that all succeeds, you can swap the file name. And there's some kind of some atomic write logic that goes on that you can read about to help that be a little bit safer.
Does that have to be done manually, or is there like a helper for that?
Oh, I'm sure there's helpers. I'm not aware of where they are. All right, I am not going to go into encoding. I think that was the last one just because I'm already way over time. One last thing I will show you though, I have the binary example here. We've been talking about text files. This does have to do with encoding, but Python is trying to read these files by default as UTF-8 encoding. If I have a file that's not UTF-8 encoding, it's gonna throw an error at me. So Python 07 binary. Anybody ever see like something like this? Codec can't decode byte, and you start to bang your head against the wall. This can in some ways be really terrible if you don't know what is actually supposed to be in the file. In this case, this is an SQLite file. I deliberately created a file with SQLite because I knew it would have content in it that would make UTF-8 unhappy. You can simply, if you have to work with a file where you really need the bytes and it's not a text file, then you just need to read it as binary instead. In which case you're going to get a binary object instead of a string object. So if you remember way earlier when I ran O2, I showed you that the object type that we got back was str. It was a string. Well, this time it's going to be a binary object. Yeah, there's a lot of output here. I'm sorry, it's going to be a bytes object. So it's a bytes object instead of a string object. And knowing the difference, knowing that you've got one versus the other is really important and something that Python 3 makes you care about, which is actually better for you because in Python 2, you might not get the error, but you might blow stuff up and not realize it. The rest of the stuff that's being printed on the screen here is padding that SQLite is using in its data file. We don't really care about what this is. The only thing you might want to see is that you can recognize some text in here, and that's because I did an insert statement in the way SQLite structures their file. It just so happened to be at the very end. And actually, there's a create table. You can also see my create table is in here somewhere. Questions about binary?
At the very beginning of that printout right there, did Python insert that V at the beginning to tell you that it was bytes?
It did, and that's good. Yeah. So when you print something that's not a string and it's a byte, so if this was a string, it wouldn't show that at all. But because it's a bytes object, it's going to have that in its representation, on-screen representation. Any other questions about bytes? Okay. Thank you.